Welcome to Algebra 2 Fall 2019 Semester Review. Topic number 1, this is not a question, this is for information only. Each summer, the members of the Drama Club at Amanda's school do various odd jobs around the school and contribute their earnings to the Drama Club's treasury. This year, their school's principal has offered to pay them to help him organize the book room. The principal gives the students two different salary options. Salary is how you make money. Let's look at number 2. Under the first option, the principal will give the students $3 at the end of the first day of work. At the end of each additional 8-hour day they work, the principal will pay the students 2 more than their previous day's salary. Under the second option, the principal will give the students 5 cents at the end of the first day of work. He will then pay them double their previous day's salary at the end of each additional 8-hour day they work. Begin your investigation of each option by filling in the salaries for the first 3 days under each option. Alrighty. Okay? So let's take a look. Okay, here we go. Okay, all right, so at first he pays them $3, okay? At the end of each additional 8-hour day they work, the principal will pay the students 2 more than the previous day's work. So that second day he's going to pay them $5. On the next day he's going to pay them $7. Notice that you are increasing by $2 every single day, okay? Now, the other option, under the second option, the principal will give the students 5 cents at the end of each first day of work. He will then pay them double their previous salary for each additional 8-hour day they work. So the first day they get 5 cents. The second, they're going to get 10 cents. The third, they're going to get 20 cents. So the rate is 2. So they're doubling, so they're going up by 2. All right? So notice the difference in the 2. Right now, option 1 pays more money. Okay. Let's go to number 3. Remember that the salary option under option 1 is $3 on the first day, and the salary on each day after that is 2 more than the previous day's salary. Under option 2, the salary is 5 cents on the first day, and the salary on each day after that is double the previous day's salary. What is true about each option? Check all that applies. That means for everything that is true, you need to put a check mark, okay? So let's compare. So here we go. Let's kind of compare a little bit. So I'm going to move this up a little so you guys can see. All right, here we go. Under option 1, that's right here. The sequence of salaries is 3, 5, 7, 9, going up by 2. Now, since I am going up by 2, okay, every single time, is that geometric or arithmetic? That is not geometric, that is arithmetic. With a common, that's not called a ratio, that's called a difference of 2. So for that reason, this one would not be the correct answer, okay? Under option 2, the sequence of salaries is 5 cents, 10 cents, 20 cents, 40 cents. Notice I am doubling, I am multiplying by 2. That is not called arithmetic, that is called geometric. And since it's geometric, it doesn't have a common difference, it has a common ratio. So this one is not the correct answer either. Next possible scenarios. Option 1, the sequence of salaries is arithmetic with a common difference of 2. Yes, because arithmetic has to do with adding and subtracting. And when they do that, they have the word difference, and different means minus. So this one is true, okay? Next, options. Under option 2, the sequence of salaries, notice I am timesing by 2. It's called geometric because geometric has to do with multiplying. And multiplying has to do with the word common ratios. Ratio is a fraction. or a whole number of 2. So that one is also correct. Neither sequence of salaries is arithmetic or geometric. Well, if it's arithmetic and geometric, that can't possibly be the correct answer. All right, let's go to number 4. The salary under option 1 is $3 on the first day, and the salary on each day after that is 2 more than the previous day's salary. The word previous means before, the day before, okay? Under option 2, the salary is 5 cents on the first day, and the salary on each day after that is double. Double means times 2, the previous day's salary. All right, now it says fill in the blanks using the option boxes to find a rule for T sub n. Now, you guys also learned this as A sub n, same thing. The term that describes the salary the students will earn on the nth day. Nth day is any day, okay? N means any day. It could be the first day, second day, third day, fourth day, it doesn't matter. All right, so let's check option 1. Under option 1, I know it is arithmetic. And since it's arithmetic, I will have a D, okay? So let's take a look. So now I'm trying to describe the salary. All right, T sub n or A sub n is equal to your first term. What is your first term? My first term is 3. So I'm going to start off with $3, and I'm going to increase it by 2 every single time. And there you have that equation, okay? Let's look at option 2. Option 2 is it's not arithmetic, it is geometric. And since it's geometric, you will have an R, all right? So we're going to start off with our first term. Our first term is 0.05 times our R. Our R is a rate of 2, okay? And I'm going to raise it to the 2n minus 1. Oops, let me do this correct. The way they have it written is kind of, I forgot the dot for multiplication. My apologies. All right. And this one I forgot to take the previous day. So this will be close dry. Okay, so this will be a dot here, and then you would have 2n minus 1, okay, because that denotes previous day, and that should be a dot, if I can get it to do a dot. There you go. And this one here is minus 1, because you need to take the previous day. There you go. All right, so there you have your equation, okay? All right, number 5. The drama club president says that option 1 will always pay more each day than option 2. Is this statement true or false? Now, depending on how many days you work, that all depends, okay? It says the key word here is always. No, it's not always going to be true, because eventually after a while, it's going to even out. It's going to be equal. And then that's when you make the difference. So it depends on how many days you're going to work. So for right now, since the key word here is always, I'm going to say this is false. Number 6. Which of the following describes geometric? So geometric has an R sequence. Check all that apply. So let's look at this first one. Notice I'm increasing by 3 every time, so that's a D. So that's not the correct answer. Look at this one. Do you see how there's a multiplication right there? So that would be a correct answer. This one, I'm multiplying times 2 every time, so that's geometric. Look at this one right here. You notice how you have 3 plus something? That plus or minus tells you, denote that is your D, so that can't be an answer. And this one, you have first term, cutting it in half. Your R is right here. That's your R, so that would be true, okay? And it's just any number. All right, next part. It says, use the figure to answer questions 7 through 8. Here's your first row, you got 1, second row you got 3, third row you got 5th. See, kind of going up a little bit. A stella formed this figure by placing a single 10 by 10 millimeters by 10 millimeters square tile on a grid that repeatedly adding rows of tiles of the same size to the existing figure. Use the word number bank to complete the following statement below. All right, let's look at the statement and we're going to choose it from here. If a stela continues to follow the same pattern of adding tiles, then the number of tiles in each successive row of the figure will form an arithmetic sequence with a common difference, okay, of, it's going up by 2. The total area is like 10 times 10, okay? 10 times 10 times 10, so you're multiplying. Will form a, because you're multiplying, will form a geometric sequence with a common ratio of, I am starting with 10 by 10, so that's 100, 300, so you're multiplying every single time, all right? So that comes out to be a ratio of 3. All right, number 8. If a stela continues to follow the same pattern of adding tiles, she will need how many for the nth, for the 100th row? So this is your n. So you have this formula right here, a sub 1 plus d n minus 1, okay? So you don't know how many tiles she's going to have. She starts off with 1 tile, and it's increasing by 2, and the n is going to be 100 minus 1. And you can type that into your calculator, and when you do, let me show you your calculator. So 1 plus 2 parentheses 100 minus 1 comes out to be 199 tiles she will need. Number 9. A ball is drawn from a height of 460 centimeters. The ball loses 25%. Now 25 is the same as 0.25 of its previous height after each bounce. To find that, basically put a percent is out of 100, so it comes out to be 0.25, okay? So she starts off with 160. So what's 160 times 0.25? See that? 40 times 0.25, 10 times 0.25, 2.5 times 0.25, 0.625. Notice it keeps getting smaller and smaller and smaller. Number 10. A ball is drawn from a height of 10 centimeters. The ball loses 25% of its previous height after each bounce. The graph models the height of the ball. So I start at 160, and then I go down to, oh, I did this wrong. I'm so sorry. Let's go back to number 9. Okay, it's losing 0.75, so 100 minus 25 is 75. Okay, which comes out to be 0.75. My bad. So this part right here, you actually take 160 times 0.75, which gives you 120. My apologies. Times 0.75 gives you 90, because it's retaining its bounce, 75% of its bounced. I thought backward. 67.5 times 0.75, 50.625. My fault, sorry. And all of these would be centimeters. Okay, because I was thinking how much they lose, but not how much they still acquire. All right. Knowing that, then here's your graph right here, okay? So it starts off 160. The first bounce will be 120. Second bounce will be 90, and so forth. What kind of sequence is formed by the height of the ball after each bounce? Now, notice it's not a straight line, so it cannot be arithmetic at all, but it can be a geometric with a common ratio of 0.75, because that's what you multiply it by. So that was 1 minus 0.25, which gives you 0.75. Next part. State whether each sequence is arithmetic or geometric. Find the common difference or common ratio and find the 12th term. Alrighty? So number 1. Notice. What are you noticing? So if I took 40 minus 31, that gives you 9. 40 minus 40, that gives you 9. 58 minus 49, that gives you 9. See a common pattern here? And I subtract it, so my D is equal to 9. Since you have a D, it is going to be arithmetic. Okay? Now it says to find the 12th term. So I'm going to plug into my formula. Your first term is 31 plus your D, 12 minus 1. So there's your N. So my 12th term is equal to 31 plus 9 parentheses 12 minus 1. 130. So if I keep going, this is going to come out to be 130. Next part. Okay, so number 1, number 2, right there. Now let's take a look at this one. So we have negative 4 minus negative 12, which comes out to be 8. Next one, 4 minus negative 4, which comes out to be 8. 12 minus 4, which comes out to be 8. So notice the minus. So that makes it a D is 8. And since you have a D, it's arithmetic. Okay. Finding your 12 terms, I take my first term. That's always your ace of 1. Plus 8, 12 minus 1. So let's see what that comes out to be. And I type it just like I see it. Okay. So your 12th term is going to be 76. All right. I'll come back to the next part in a little bit. Actually, let's just keep going. And finish unit 1. Number 13. Let's look at number 13. So when I put 3 minus 1, I get 2. 9 minus 3, I get 6. You see how those are the same? So I know it is not arithmetic. Okay? So let's try if it's geometric. Ready? Second divided by the first is 3. 9 divided by previous one is 3. 27 divided by previous one is 3. Notice the division. So that tells you the R is 3, and since you have an R, that makes it geometric. To find the 12th term, you're going to use the formula right here. That's the formula you're going to use. Okay? Take your first term times your DR, which is 3. Your N is 12 minus 1. And you can just type that into your calculator. Ready? 1 parentheses, 3 parentheses, raised to 12 minus 1. Comes out to be 177,147. 177,147. Look at 14. All right. 5 minus negative 1 is 6. Negative 25 minus 5 is negative 30. So this cannot be arithmetic. Okay? So let's see if it's geometric. All right. 5 divided by negative 1 is negative 5. Negative 25 divided by previous term is negative 5. 125 divided by negative 25 is negative 5. Notice they're all the same since they are division. Your R is equal to negative 5. And since you have an R, this is considered geometric. Let's see if we can find the 12 terms. First term is negative 1 times your R, 12 minus 1. Type in my calculator, negative 1 parentheses, negative 5 raised to the 12 minus 1. It should be a big number. 488,28125. And how do we say this? 48,828,125. We will continue in a moment.